Welcome to the second part of lecture number 1. Now we're going to explore the difference between the lower and upper estimates from the previous example. So if we copy those graphs from above, we have the upper estimates, these red rectangles, and we have the lower estimates, these green rectangles. And if we take the difference between them, we subtract them, we'll get, well, this first rectangle minus this first rectangle that's green, which gives us a little tiny, we'll make it blue rectangle that's left over. And then this second red rectangle minus the second green rectangle gives us another tiny rectangle. And then the last rectangle's difference gives us a third little rectangle. So we take the difference, we get a bunch of rectangles. And now we're going to smush all those rectangles together, stack them on top of each other, and think about the dimensions of this single rectangle that results. So first off, the width of this rectangle is 1, or delta t. It's the change in time that I've chosen to subdivide the velocity. And the height is the last velocity minus the first velocity. You can think of it as the corners. So v of 3 minus v of 0. Let's write this down. So the difference is 103 feet per second minus 66 feet per second, all times 1 second, the delta t, which works out to be 37 feet. And if we had just gone up to our lower and upper estimates from above, we see that if we take the difference of those two things, we get 37 feet. So this geometric way matches what we would get numerically if we just took the difference. So what do we learn from this example? Well, we learn a general formula. And that is, if the velocity is increasing over an interval, then the difference between the upper and lower estimates of distance traveled is this formula, VB minus VA times delta t. And now we can make an important observation. Observe that as the delta t decreases, this difference also decreases, suggesting that the lower and upper estimates are converging to a common value. So if we took delta t equals 0.5, then the difference between the upper and lower estimates would be 18.5, half of what it was before. This suggests that as delta t goes to 0, the difference also goes to 0. So graphically, what's happening? Well, the upper estimate is getting closer and closer to the area under the curve, and the lower estimate is also getting closer and closer to the area under the curve. So both estimates are approaching the exact area under the curve. Let's draw a picture of that.